How is that possible? That shouldn't be possible. Okay. Let's see that. Hmm. Okay. It's working. So basically, what I'm doing here is I have basic TD implementation. I have a whole sort of framework where I'm adding RL algorithms. I can add. Actually, this is pretty shitty. Uh, I'm supposed to add function approximation, which probably means I'll have to add neural networks, which I don't fucking know how to do. I've never implemented that, but we'll see. Anyway, currently I'm supposed to learn how to evade a chaser in a tag game. Basically, each player is a circle. How to run away from him. And my state in the MDP framework, as defined here, is pretty simple. This. So, wait, this is not correct. Okay. It's just STD pair for XY for representing a vector as over discretize the state space so that because I'm not using function approximation, it's a tabular TD. Um, this is tar- tagged velocity, tagged player velocity, my velocity, and the distance between us. And then the action is the resulting vector, which can be any one of these. So it's 8 directions or stop. And the agent's supposed to learn how to evade based on a very simple reward mechanism. If new distance is 0, i.e., if I'm caught, then it's a negative reward, otherwise, it's 0. And it doesn't work perfectly well, but it works like okay ish. Though rendering the game, oh, by the way, this is the whole RL thing is implemented in C. The tag game itself is in Java. Rendering really slows down things, so I'm trying to run the game in memory, meaning no visual anything. Because the game works fine with this type of running, I should be able to demonstrate that. Yep, you see, he's a little foolish, but oops, and I have that problem now. I didn't get this before. I'm getting it now. Apparently, my reset function of the state. This is the bug I'm trying to solve. I thought I don't have it in the normal run, but apparently I do. So the problem is the reset function returns a terminal state, which should never happen. And that is bizarre. I don't know how that is happening. That should never happen. Oh, what the fuck? That shouldn't be possible. Because here, obviously, if me equals tag player, only then is that a terminal state. Can me equal, what is me? Me is passed in. Okay. I actually understood this last time I looked, but now I forgot what's the problem. So it's basically RL player. If the RL player is the same as the tag player, that means there's a problem with the tag player because this is predetermined. So I would assume player count is 2. This is fine. Set tag. Does this shit not work? No, I specifically. That doesn't make any sense. But either way, honestly, that seems like I can just do this. Just realized that this is pretty dumb here. Oh, really? That's disturbing. I guess that works. Am I still all alone here? Yeah. Okay. Well, that shouldn't be possible, actually. That should work fine. I'm just waiting for the bug to happen. This you can bump this up to like 2000 FPS. Training way faster, but the in-memory implementation doesn't have a cap actually. So I just multiply by the time passed. I mean the movement of the objects. So there's no constant frame that I'm looking for there because I don't really care about that. It's not a multiplayer game or something. I'm just looking to train fast, and my laptop is burning right now. Well, that's weird. I don't know if I fixed the bug. I can no, wait. I can just do this. Um, I'll copy this. My favorite thing to do. Use a text editor. Too primitive. Okay. So now I'll just go here, add a condition. Okay. Tag player. Wait, what? Where did I use this shit? Set tag, no? Ah, okay. No, that's not what I meant. What I meant is random player equals players dot get RL player index. Maybe, yeah. Hmm. Have to run that. Okay. Sheesh, my laptop is burning. Okay, we got one person. I don't know what that is. Crap. Right. So I'm just waiting for the. Wait, I have a cooler. Actually, no. One sec. All right. I better do this before this thing explodes. Oh yeah, that's stuff. Okay. Okay. I don't know what the fuck's going on. In memory, maybe. It's a bit faster. Shouldn't make a difference. Yeah. Did I not run the debugger there? Wow. So that actually does not happen. That's sad. The fuck? That's a bit weird. I mean, you would assume that after initialize game, handle tagging logic. Oh, oh, I see. Fuck. Okay, I see. It just so happens that they're spawned exactly on the same spot, which happens rarely, but yeah, I see. Well, we'll just do this array list. What does this return? This returns static info. That's great. Positions. Um, I think if I do this and I do this, then I do this. I don't know Java. Fuck it. New arrays list. By the way, the reason I'm doing this in Java is because this was actually sort of like something from a lecture of my professor. And then I just took his game, which was about something else. It was about movement algorithms, and I changed a bit, and then I decided to use it for reinforcement learning. So that's the story. Would have been much better in C++, of course, but it is what it is. I hate Java. Contents of collection are updated, but never queried. Okay, why do you care? I'm gonna query it. Do, right? Do while. But of course, this goes here. No. Then this guy in. Is there something like that? In. Index of, I think, can work here. Position is not equal to, is equal to. Wait, what does this return? Is not equal to, probably. I have the dogs on this, or minus one if this list does not contain the element. So as long as it does not contain, so as long as it contains the element. Oh, there is that. Okay, great. So as long as it contains the element, continue doing that. It should work. Okay, let's see if that happens ever again. Alright. Seems. What the fuck? That's insane. So I was wrong. Oh, send game state. I don't know why I'm not doing that, honestly. Just come here, do this. Can't put a breakpoint. Oh yeah, this helps. Okay. This shouldn't be possible, honestly. I hate JetBrains too. Fuck. What the hell is wrong with this shit? Ah, there's no such thing. I renamed that. Okay. Initialize game position. Okay. Still inexplicable. This never breaks. I don't have an idea, to be honest, at this point. Actually, what I ought to do is simply print. Can I print the game state somehow? I don't know. What's the function? Yeah, I can do this. Uh, yeah. Salt. Yeah. Oh, that doesn't tell me anything. Actually, that's not what I wanted. It was. It was may get static info. Right. Is there two string? There should be two string. Return this that. What is this? This is not what I wanted. But maybe I should do that. Or maybe I shouldn't. Well, that's all I care about anyway, so I would assume that tag play no RL player or agent in other words, and then tag player is I guess just +1 in this case because this guy is 0. This is just debug code. Don't have a better idea here. Okay. You see they're very close to each other, which is what makes me think that they're not the same. They cannot be the same. So how the fuck does this guy receive what? Wait a second. That's not even the state. That doesn't make any sense. That's not even the state. Two people. Okay. That's interesting. That doesn't make any sense here. That should not happen. It doesn't make any sense. I serialize the game state. These two are not equal to each other, obviously. This guy is clamped and rounded. Can't be. Wait a second. Can this ever be 0, really? That would be bizarre. That's the case. That's really bizarre. Okay. That's a word, actually. Okay. 3 people. Hope that's not everyone from my family. Okay. Well, this is interesting. Feel free to type in chat if these are not bots or something. ask questions about whatever I'm doing. What? No way. This is not possible. Legit. They have different positions, yet they're same players? How is that possible? Okay. That's wild. Uh, is that even possible? Okay. Me, 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 and I guess get name is the best indicator for a player. And then tag player. Let's see if that works. So what's happening here is the environment resets to a terminal state, which doesn't work well with TD or any MDP algorithm, I think. What the fuck? That's that's wild. That's wild. They have different positions, but they're the same player. I honestly don't know how that happened. I'm missing something. Minute game clear. Tag change time. That ain't possible, man. Let's just see that real quick. Hmm. Prediction objective. All right. Perfect. So, setting non-RL player P2. That's correct. So does this shit not work? What? Why am I even doing this? Tag player equals new player. Okay. Tag player dot set is tag true. No. Isn't that what this? What the fuck was I thinking? Okay, that's weird. Oh no. Okay, I see. That will update the other ones to false. Okay. That's good. Um, what the fuck? Setting a non-RL player. Setting non-RL player. P2. That's correct. Okay, I'll give that a shot too. So we're printing. Let's print everything. Um, RL player. Oh, setting non-RL player. Okay. RL player now. I guess like this. And then players dot get RL player index get name. And I'll start that. Start that. This is depressing. RL player now silly. Pete. What the? Really? I don't know why I didn't think of that. Really? Like, that's basically what I need to do here. Uh, Init game. Yeah, that's. I don't need that anymore, actually. Fuck. You know what? Get random position. Screw this. Screw this. Screw this. 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 I don't need any of these. What I do need is Now, okay, four players. Okay, players. If players equals not tag player and tag init game, right? I wouldn't want to do that there, no. Yeah, boolean should invalid reset false, invalid reset true, if invalid reset init game. I guess so. Let's see that. I think it won't happen anymore. Yeah, that was the bug. Anyway, uh, we can remove these. Boom, 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 boom. That's there. Okay, that's all I wanted to do. Get diff. Yeah, let me delete those system out print lines real quick. I don't know what that is. What's that? Hmm, doesn't matter. Yep, I think that's fine. Now it's significantly faster at training DRL. No rendering now. Anyway, we gotta move to neural networks. Okay, by assumption, we have far more states than weights, so making one state's estimate more invariably means making others less accurate. Of course, because that's the whole point. Otherwise, that would just be TD. We're obligated then to say which states we care most about. We must specify a state distribution, mu of s larger or equal to 0, sum of s mu s equals 1, representing how much we care about the error in each state s by the error in the state s. How much we care about the error in each state s. By the error in the state s, we mean the square of the difference between the approximate value and the square of the difference between the approximate value and the true value, but we don't know the true value. Weighting this over the state space by mu, we obtain a natural objective function mu squared value error. Go over all states, multiply by how much you care about that state, by the mean square error. The square root of this measure, VE, gives a rough measure of how much the approximate values differ from the true value that is often used in plots. Often, μs is chosen to be the fraction of time spent in S. That makes sense. Under on-policy training, this is called the on-policy distribution. We focus entirely on this case and continuous times the on-policy suits the stationary distribution until under pi. That makes sense. The on-policy distribution is a little different in that it depends on how the initial states of episodes are chosen. Let h of s denote the probability that an episode begins in each state s. And let... Okay, this is a bit of a fuckery. Let h of s denote the probability that an episode begins in each state s. And let n of s, or whatever that's rho, I don't know, probability that an episode begins in each state s, and that denote the number of time steps spent on average in state s in a single episode. So you got the beginning, anything in between times is spent in a state s if episodes start in s. Time is spent in a state s if episodes start in s. Or if transitions are made into s from preceding state s. It's not possible. Why do you need the first probability then? From preceding state s. PC will probably burn up. I need to stop this. Okay. Let's see this then. Yeah, it's pathetic a bit, but still. And this is not solvable with vanilla TD. Solve the bug where the environment resets to a terminal state where tags the URL. Okay. That doesn't help anything. Note the number of time steps spent on average in state S in a single episode. Time spent in a state S if episode starts in S, or if transitions are made into S from a preceding state S prime, in which time is spent. Okay. Never mind. Okay. So the time steps spent on average in a state S in a single episode equals to the probability that an episode begins in each state S. So this is also the average, kind of, where it begins in state S, plus going through all these are parent states, going through all previous states from which it can be transitioned into S, and then the probability, and then all actions with which we can. So that's, I have to draw on my phone. A backup diagram. So we have as mm, as 1, 2, 3. Okay. So all of those actions, the probability of taking that action and the probability of, upon taking that action, transitioning into that state multiplied by so this basically tells you what is the probability of take of some s prime transitioning into s, whereas this tells you how likely s prime is, not how likely, how many times on average in a single episode do we see this guy. And that's for all possible previous states, plus the probability. That doesn't make any sense. Okay, time to ask our DeepSeek friend what the hell is going on here. Why would what? You okay? Okay. What? Hmm. Okay, I guess that makes some sense. Okay, 60% understood that. The system equation can be solved for the expected number of visits. The unpolicy distribution is then the fraction of time spent in each state normalized to sum to 1. I mean, what? This is just weird syntax, but yeah, I get it. Basically, this is just one. It's an actual choice without discount. If there's discounting, it should be treated as a form of termination, which can be done simply by including a factor in the second term of 9.2. Here, somewhere here. The two cases continuing and observed behave similarly, but with approximation, they must be treated separately in formal analysis, as we will see repeatedly as part of the book. This completes the visualization of the learning objective. But it's not completely clear that the VE is the right performance objective for reinforcement learning. That our ultimate purpose, the reason we are learning about the functions to find a better balance. The best value function for this purpose is not necessarily best for minimizing VE. Nevertheless, it is not yet clear what a more useful alternative goal for value prediction might be. For now, on VE, an ideal goal in terms of VE would be to find a global optimum, a weight vector VW star for which VEW star is less than equal VEW for all possible W. Reaching this goal is sometimes possible for simple function approximators such as linear ones, but is rarely possible for complex function approximators such as threshold neural networks and decision trees. Short of this, complex function approximators may seek to convert instead to a local optimum, a weighted vector W star for which VEW star less than equal VEW for all W in some neighborhood of W star. Although this guarantee is only slightly reassuring, it is typically the best that can be said for nonlinear function approximators, and often it is enough. Still, for many cases of interest in reinforcement learning, there is no guarantee of convergence to an optimum, or even to within a bounded distance of an optimum. Some methods may in fact diverge, with their V approaching infinity in the limit. Wow. The last two sections outline a framework for guiding a wide range of functional methods for calibration with a wide range of functional approximation methods using the updates of the former to generate training sample for the latter. Wide range of reinforcement learning methods for error prediction with a wide range of functional approximation methods using the updates of the former generate training samples for the latter. Also describe a VE performance measure which takes these methods. Also describe the VE performance measure which these methods may aspire to minimize. The range of possible function approximation methods is far too large for all, and anyway too little is normal. Plus, to make a reliable validation or recommendation of necessity because there are only a few possibilities. In evaluation recommendation, in the rest of the chapter, on function approximation method based on gradient principles and on linear gradient descent methods in particular. We focus on these methods in part because we consider them to be particularly promising and because they reveal key theoretical issues. So is that they are simple and our space is limited. Stochastic gradient and semi-gradient methods. We now develop in detail one class of learning methods for functional approximation value prediction. Those based on stochastic gradient descent (SGD) methods are among the most widely used of all functional approximation methods are particularly related to online enforcement learning. In GD, the weight vector is a column vector with a fixed number of real valued components. I didn't want to go there. Oops. I want to do that. And the approximate value function VSW is a differentiable function of W for all. Okay, differentiation for two parameter function. Maybe Paul's notes. Let's see. I think it's partial derivatives. Yeah. No, then we can brief this kind of limits out of the way. To present obtain the original flight of more than one variable before we actually start the one we call it given a function of one variable. The derivative represents the rate of change of the function as x changes. This is an important function of derivative, and we're not going to want to use the function more than one. The problem with function is if there is more than one variable, in other words, derivative for only one of the variables change, if we want more than one of them to change. In fact, if we're going to allow more than one variables to change, there are a lot of ways for them to change. For instance, one variable could be changed faster than the other variables in function others. So it could be possible for changing differently when we allow one or more variables to change. We will know the ways in the different with all of these in this section. We're going to concentrate exclusively on only changing one of those to the variables. We will because we're going to only allow one of the variables to change, the now become fairly simple. This such discussion of single 2x. Let's rewrite the wish to function checkpoint AB. If we hold y fixed and allow x to vary, and if we hold allow y to vary. That's confusing. Uh, Okay. With partial derivatives, we will always need to remember the variable that we are differentiating with respect to, and so we subscript the variable that we differentiate with respect to. We'll shortly be seeing some alternate notation for sure. You note as well that we usually don't use AB notation for partial derivatives. That implies we're working with a specific point, which we usually are not doing. The most time is just to use so the partial working as. Now let's quick example of shunting with that's crazy. Okay. Pretty sure. Okay. Okay, whatever. Wait. And the approximate value function is a differentiable function of W. Approximate value function is a differentiable function of W. Wait, what does that even mean? It's differentiable function. It's a function of w. It's not. Okay. Okay. When the text is approximately the definition of w for all, it means that it depends on the weight vector w. Obviously, it also depends on s. Is smooth and differentiable. Continuous, I guess. Okay, I think this is enough.